Hello, students. It's been a while since we've done this way of learning, but I wanted to give you guys an opportunity to have some experience with identifying amplitude and period in a sine function. This springs off the stuff that we dealt with today in class. And so I want to begin by just pointing out to you that we're gonna always have the form in these examples today. We're gonna have the form of our function as y is equal to a sine bx. Now remember, we discussed that if we had y, the parent function, hang on a sec here, the parent function y is equal to the sine of x, we had an amplitude of 1, and we had a period of 2 pi. Now, understand that what I'm about to show you here is exactly the same form as a sine bx. Identify with me that, and actually point out, you should be able to follow along with this, that the a value here is 1. And then that the b value sitting in front of the x, the coefficient of that, is also 1. And so it's known, it's a known fact here that, let me get this erased, see if I can figure this out. They've changed all of this to some extent. Let's see if I can get an eraser. Okay, there it goes. Great. So keeping that in mind, when we have this function y is equal to a, the sine of bx, we can identify from those values in the function the amplitude and the period. And so by definition, the amplitude, again, is that how far it is from top to bottom, and you take half of that to give you that amplitude. So we're going to take our a value, and it will always be, hang on a sec here, we got pen issues. And I don't like this, but oh well. Our amplitude will always be the absolute value of a. So whatever your coefficient is in front of the sine, that will automatically give you that amplitude. It is measuring, again, half the distance from top to bottom, which again always shows up as the coefficient of your function. So then your period is associated with that b value. And so the period is always going to be found by taking 2 pi and dividing it by whatever that b value is. Let's look at an example, and then we'll check it also on Desmos. Let me see if I can do this without, yeah, that's what I figured. Let's see if it'll do this. There we go. Okay, so that's working. So we'll check this on Desmos here, but let's take this function that we have here right now that is y equal to 4 sine 2x. We should be able to say that our amplitude is going to be just 4. Now, if that was -4, there was a -4 sine 2x, which could happen, the amplitude is still going to be 4 because, remember, we're going to take the absolute value of a. Okay, and so then, well, what's our period in this case? Well, your period is going to be found by taking your b value, identify your b value. Your b value is 2. So you're just going to take 2 pi and divide it by 2, which is just pi. So what does that mean? Before we jump onto Desmos, remember, period is the length in which we don't see any repeating of our function. This sine wave is going to be like every other sine wave. It's going to look like that for a period. So our job is to identify them. Well, what is that period? Well, that distance from there to there should be pi. So let's jump over here to Desmos and check that. So if I turn this on, we should be able to see now there's lots of waves here. So what I want you to do is focus. Well, where is that period of pi taking place? If you just notch it from 0, 0, look, there's no repeat, no repeat, no repeat. This is all unique, all unique. And then once we get here, one full period of that function has taken place. Now, if I showed you the whole thing here, I could just zoom this out a little bit, out a little bit. You'll see that we have this repeating starting to happen at this point. So from pi to 2 pi, hey, there's another period of that same function. So keep that in mind as we're discussing these things and figuring out what exactly is going on with all of this. I want you to pause the video then. I want you to look at the second example that I have here in front of you. Y is equal to sine of x over 4. Identify the period and identify the amplitude. So pause, take a look at that. All right, so hopefully you did that work. We should see that our amplitude here is going to be 1. And then our period is going to be, oh, well, what the heck? What's B? B is not 4. B is 1/4. So we're going to end up with a complex fraction, but we're masters at that at this point. Like we're easily dealing with this, right? Right? Yeah. So our period is going to be 2 pi divided by 1/4. Well, we invert and multiply there. So guess what? The period of this thing is going to be equal to 8 pi. I encourage you, when you're done with this video, go check that out on Desmos. And if I'm wrong, email me and tell me, Mr. May, you're wrong. But I think I'm doing okay here. You might want to check on me to make sure. You know, I make mistakes. All right, let's keep moving on with this. So I want you to look then. Well, what happens if they present us with a graph? Like, let's say they give us a graph and they're like, hey, this thing's freaking out. What is the period and the amplitude? So I would encourage you here, take a look at this graph, and in your mind, you should be able to determine, well, what is both of those things? Remember, amplitude is half the value of from top to bottom. What I see here, and let's make sure I'm doing this. Hopefully it's still in pin mode. Yeah. What I see here is that distance from, oh, look, hey, it's 0.5 up there. It's negative 0.5 down here. So this is a halfway and a halfway to 1. So that distance is 1. Well, half of 1. Okay. Hey, there it is. Our amplitude is equal to 0.5. Okay, well, what's the period? Well, trace out a unique or non-repeating part of the function. And then once you get to there, it's going to start repeating again. So there is one period of that function. That length, hey, it's right there, is pi. So our period in this one is pi. All right, kids, I encourage you, go look at the assignment that I've given with this video. Both these will be in Canvas. It's been a joy and a pleasure to teach you guys, and hopefully I'll see you in the future. All right, have a good day.